Good evening. Today we'll be talking about the difference rule. The difference rule is another technique that you can use to find the derivatives of functions. At this point in time, I've covered a good number of them, but I have a couple left, and I want to complete out all the different methods you can use for finding the derivatives. 3 disclaimers. I can't write straight to save my life. I'm sorry. It's just not going to happen. 2, my 1s look like this, and my 7s look like this. Not that and that. Not this and this, or that. And also, I can't really spell. But this is math, not English, so we should be okay. With that in mind, I'm going to go ahead and get started with the definition and notation of the difference rule. I will have my notes, questions, and solutions as a comment pinned with a link to a PDF as soon as I upload the video. So, let's say that we have a function d of x. And we're going to say that d of x is equal to x raised to some number minus x raised to some other number. The only reason why I don't want them to be the same number is because if they are the same, raised to the same exponent, then you don't need to use the difference rule. You can just divide them, subtract them, and then use the power rule. And I've already covered that. So let's define our variables here. D of x is our function that we will use the difference rule on to find the derivative. So I'll just say the function that we will be using the difference rule on. X is our unknown variable. And we know that n and m are just any given number. And for the sake of this, I will say that n cannot be equal to m, because if they are, you don't need to use difference rule, you just use the power rule. For example, if it's x squared minus 2x squared, well, we know that's negative x squared. That's not a difference rule, that's a power rule. So there's really no need to go through all that. So let's go ahead and write the actual definition of it. The first derivative of this function will be equal to the number times x raised to that number minus 1 minus m times x raised to that number minus 1. Or if you've already watched my power rule video, then using the power rule, we can just say that the first derivative is actually equal to the derivative of this first one. So we'll just say x of n prime minus the derivative of the second one, which is x of m prime. That's really not the correct notation for it. If I wanted to be mathematically correct, a more accurate way of writing it would be the derivative of x raised to the power of n with respect to x minus the derivative of x raised to the power of m with respect to x. If I'm being technical. Technicalities aside, there's a couple different forms I want to familiarize you guys with. So I'm going to erase that. We'll keep that. So the first thing I want you to consider is, say you have y is equal to 1 over x. You also have y is equal to x squared. You also have y is equal to x plus 3 times x plus 4. You also have y is equal to x plus 3 over x minus x plus 4. And you also have y is equal to x squared plus natural log of x. So let's go through these. This is a reciprocal rule. I'll use R. This is a power rule. We'll say P. This is a product rule, so we use little p. This is a quotient rule, so we use Q. And this is a sum rule, which we'll say S. I haven't covered sum rule yet, but every other rule I've actually covered. So if you want to know what you would do to solve these types of questions, you can go refer to my older videos, because I've covered that in detail. And because I've covered those in their own separate videos, I will not be going over them in this video. But that's just so you can identify the different kinds of forms. Now that we've gotten the notation and the derivatives out of the way, we can go ahead and do some practice questions. So our first question that I have, we have y is equal to x cubed minus 27. Now, if we were trying to factor this, I had a video on factoring, my test video, my very first one. You would want to find the cubed root, but since we're finding the derivative, it's actually much easier than that. We know the derivative of a constant is 0 using the definition of a derivative, which is something along the lines of the limit as delta h approaches 0 of f of x plus h minus f of x over delta h, and you would plug in all that and solve. But since we know the shortcuts, we're not going to concern ourselves with that. But that's the definition you would use to actually find the derivative of a constant is 0. We can just go ahead and take the first derivative of y with respect to x. Since we know that this is just a power rule, it's just equal to 3x squared. Nice and straightforward. So that is our answer to the first question. Our second question. We have y is equal to x squared minus 4x. So this is also a product rule, but we'll use product rule twice. We will use the product rule once here, and we will use it again here. This will be the second time we use it. So we can say that our first derivative is equal to 2x minus 4. And that is our answer for question number 2. Question number 3 is a slightly more lengthy one. So I'm actually going to erase both of these off so we can have some space for question 3. So for question number 3, we have y is equal to e to the x minus secant of x. Now, you'd probably see it more as secant of theta, but for the sake of this question, we're using x as a variable, so it doesn't really matter if it's theta or x. If we want to find the derivative of this one, the derivative of e to the x is e to the x, so that's really straightforward. If you don't have the derivative of secant of x memorized, you kind of run into a roadblock. You can cheat it. You can say the derivative with respect to x of secant of x is equal to, the derivative of secant of x, right? That's correct, but you won't get any points really for that on the test. But if you don't know what it is, writing that is better than leaving it blank, in my opinion. So that's always something to consider. So, if you ever get on a test and you have to do that, that's what you can do. But we can also just, if you have it memorized, it's also easy. So the first derivative of this function is equal to e to the x minus the derivative of secant of x is secant of x tangent of x. Okay, maybe easy isn't the word for it, but once you have it memorized, it's straightforward. And that is our answer for question number 3. It isn't really, in my opinion, I don't think it's really a matter of, well, this question's easy and that question's hard. It's more like you have questions that are intuitive and straightforward, and then you have the questions that are not so much. But that's just math. For question number 4, we have y is equal to the natural log of x minus 7 times x to the 7th power. Again, we'll just, if you know the derivative natural log of x, then you got it. If you don't, you can write it as this, the derivative with respect to x of natural log of x. But we know that the derivative of natural log of x is 1 over x. So the first derivative of y is equal to 1 over x minus 7 times 7 is 49. Times x to the 6th. And that's our answer for question 4. Question number 5 is a little bit different. It's a trig. Well, it's a hyperbolic. So let's go ahead and do that one. Once you get the actual process of the difference rule down, it's pretty straightforward. It's not the worst thing in the world. So for question number 5, we have y is equal to the hyperbolic sine of x minus the hyperbolic cosine of x. These functions are not exactly the same as sine and cosine. If you had sine of x, the derivative of sine is cosine. If you had cosine of x, the derivative of cosine is negative sine. In this case, if you had the hyperbolic sine of x, the derivative of the hyperbolic sine of x is equal to the hyperbolic cosine of x. And if you have the hyperbolic cosine of x, the derivative of the hyperbolic cosine of x is hyperbolic sine of x. Almost a tongue twister. So the only difference is everything stays positive with the hyperbolics. The TLDR of trying to say that 10 times fast. So with that in mind, we can say that the derivative of y with respect to x is equal to the hyperbolic cosine of x, since that's the derivative of the hyperbolic sine, and the derivative of the hyperbolic cosine is the hyperbolic sine minus the hyperbolic sine of x. Pretty convenient that it barely changed form there. But sometimes math really do be like that. Question 6 is a question that I made just so I could squeeze in a lot of derivatives without having to make a second video. Call it lazy, but when you see the question, you'll second guess that. So for question number 6, we have y is equal to the arc sine of x minus the arc cosine of x minus the arc tan of x minus the arc cosecant of x minus the arc secant of x minus the arc cotangent of x. As nasty as this question is, I'm not doing it because I think you would get this exact question on a test, but I do think you would get a question that would ask for the derivatives of one of these. So this question is a really nice question for me to go ahead and show you what the derivatives of all these are. So, I mean, there's really not too much to say on this one. We're just going to go ahead and do it all in one go. So what we write down for the first one will be our final answer. dy dx is equal to, we're going to do this nice and slow. The derivative of the arc sine of x is equal to 1 over the square root of 1 minus x squared minus the derivative of the arc cosine of x is equal to negative 1 over the square root of 1 minus x squared. Notice the only difference between the derivatives of the arc sine and arc cosine is a minus sign. The derivative of the arc tangent of x is equal to 1 over 1 plus x squared. The derivative of the arc cosecant of x is equal to, let's put the minus out here, parentheses, minus 1 over x times the square root of x squared minus 1. So the only difference from this one and the arc sine is now there's a negative 1 and there's an x out front and you switch those two. The derivative of the arc secant of x is equal to positive 1 over x times the square root of x squared minus 1. The only difference between the arc secant of x and the arc cosine of x is this went from a negative 1 to a positive 1. Then there's an x out front and you switch the two underneath the radical. And lastly, the derivative of the arc cotangent of x is equal to 1 over 1 plus x. So the difference between the arc cotangent of x and the arc tangent of x is that the arc cotangent of x, the x has a degree that is 1 less than that of the arctan function. Now what we can do is we can distribute out some -1. So -1 times -1 is +1. -1 times -1 is +1. And this is our final answer. If you know the derivatives, it's not too bad. And that's all I have for you guys for the difference rule. So if you guys have any questions or any future video topics, please let me know in the comments section. I hope you guys learned something from watching this video. Thank you guys for watching, and I hope you have a nice day.